Okay, I'm going to do another example of solving equations that contain rational expressions. Let's consider this equation right here. Right off the bat, I want you to notice that we cannot have x equaling -3. If x equals -3, these denominators become 0. That's going to become a key point in this particular example. Now, just as we did in earlier examples, you look across here and you look at all of the rational expressions, check out their denominators, get a common denominator. Well, this is a pretty simple example here because the only denominator that's there is x plus 3. So the least common denominator is going to be x plus 3. And remember, what we did here is we took that x plus 3 and we multiplied both sides of the equation by that common denominator. Okay, now let's work that out and see what we get. On the left-hand side, we're going to be getting, let's see, x plus 3 times x minus, well, let's see, if I go x plus 3 times the 6 over x plus 3, those cancel out. One's in the numerator, one's in the denominator, so I'm just going to get 6 there. And then on the other side, the x plus 3 is going to cancel with the first term this time, 2x, and then plus 2 times x plus 3. Okay, so that's the key step there, is that we recognize the LCD, you multiply by the LCD, and that has the effect of clearing the fractions. Okay, now let's go on and solve this thing for x and see what we get. On the left-hand side, let's see, I got x squared plus 3x minus 6. And on the right-hand side, let's see, we're going to end up with a 2x here, 2x there, 4x, and then the 2 times the 3 is a plus 6. Now watch me closely, because this is where everybody drops signs all over the place here, so make sure I don't make any mistakes. I'm going to take these terms now, and I'm going to bring all of these terms over to the left-hand side, and let's see what happens with that. I'm going to have an x squared, subtracting a 4x, so the net effect over here is going to be negative x, and I'm going to be subtracting a 6 from both sides, so again what I'm going to have left over on the left is that, and that whole thing is going to equal 0. Now this should start looking awful familiar about how do you solve a quadratic equation. We solve a quadratic equation by bringing everything over to the one side of the equation, writing it in standard form, and calling it equal 0. Well, heck, now we can just turn around and solve that as usual. Turns out this does factor, and it factors into x minus 4 and x plus 3 equaling 0. And remember, we apply our zero products rule there and say that, well, that means that x can equal either 4 or x can equal -3. All right, now, so we've got 2 answers. So does that mean we have 2 answers for the problem? Well, maybe. Some of these problems do have 2 answers. But in this particular case, because this one right here, this x minus 3, all the way up top, we said that x can't be equal to -3. And so that can't be one of the solutions. So the only solution to this particular problem is x equals 4. And again, what you would typically do is take this x equaling 4, plug it back into the original equation, and make sure that it makes a true statement. So in this particular example, we use the same technique of clearing the denominator by multiplying by the LCD. Okay, but we also had to notice up front that we had some limitations, we had some constraints on our values, because sure enough, when we came down to the bottom, one of the potential candidates that we came up with for a solution for this problem was, in fact, the very thing that it couldn't be. So that left us with only one solution for this particular problem.